Section 5.1 is about inverse functions. So let's take these two functions and compose them like we did earlier. So in this case, I start with f, and anywhere I see an x, I plug in all of g. And then I continue on with f. And then I simplify. So these two 6's will cancel, leaving me with this. And then these two 2's will cancel out, just leaving me with x. So what's happening here is the function f is taking things from one set and moving them to another. And then the function g is coming along and moving them right back to where they started from. And whenever two functions do this, we call them inverses. And we denote them by a little inverse sign, like that, a -1. And the first problems you're going to run into look like this. You're going to be given sets of ordered pairs, asked for the domain and range, then the inverse, and then the domain and range of the inverse. So we already know how to do the domain and range of this, so let's do that. The domain is just a list of first elements. And the range is just a list of second elements. Now to find the inverse on this, all you do is switch x's and y's. So inverses, we just take each ordered pair and flip it around. So we've just flipped all the ordered pairs around. That is the inverse. And when I look at the domain of the inverse, and the range of the inverse, I find that the original domain has become the range, and the original range has become the domain. So inverses flip x's and y's, they flip domains and ranges, and if we have a graph of an equation, the graph of the inverse equation is going to be symmetric around the line y equals x. So just remember, symmetric around the line y equals x, x's and y's, domains and ranges flip. So the next type of problem you're going to run into is going to be this type. You'll be given a function, and this is the first one we worked with, and you're going to be asked, is it 1-to-1? And if it is 1-to-1, find the inverse. And then you'll look somewhere in the book and you'll look for the definition of 1-to-1. And it's going to say, for it to be 1-to-1, if f of a equals f of b, then a equals b. So let's prove that algebraically. So let's replace this x with an a in one of them. And let's replace it with a b in the other one. And our job is to prove that a equals b. So let's add 2 to each side. And let's divide each side by 6 now. And we've proven that if f of a equals f of b, then a equals b. So it is 1 to 1 and it has an inverse. If you're lucky enough to have a graph of this, and you can graph this on your calculator if you want to, we have a test called a horizontal line test, and this is not the graph of this function. Horizontal line test says if I can draw a horizontal line and hit my figure in more than one point, it's not 1 to 1. So this is not 1 to 1. If I actually graphed this equation, I'd have a line with an intercept of -2 and a slope of 6, so something that looks kind of like that. Here, I could not draw a horizontal line through and hit in more than one point. So this is 1 to 1. It does have an inverse. Basically, when you're looking to see whether they have inverses, look for powers of 2 or even powers on the exponent, on the variables. If you have fourth powers, second powers, they will not be 1 to 1 and won't have an inverse. If you have odd powers, like 3 or in this case 1, generally you will have an inverse and it will be 1 to 1. But now that we've shown it's 1 to 1, let's find the inverse. So the steps for finding the inverse are fairly simple. The first thing you do is replace the f of x with a y. Second thing you do is swap the x's and y's. And then you solve for y. So I'm going to bring this 2 over and change its sign. And then I'm going to divide by the 6. So y equals x plus 2 over 6, which happens to be my inverse function. And this is the set of steps you will always follow. So let's try a few of those. Let's try this one first. Replace the f of x with a y. Swap the x and the y. And then solve for y. So I'm going to bring the 1 over. And to get rid of cubes, I use cube roots. So I'm going to take the cube root of each side, and that will cancel out there. So y equals the cube root of x minus 1, and that is my inverse function. Let's try another one. Same basic idea. A little more difficult though, because I have things both inside the radical and outside. But the steps are exactly the same. Start by replacing f of x with y, and then swap the x and the y. And then I just have to solve for y. And I need to get rid of that cube root somehow, but I can't do anything with this 2 hanging around. So I'm going to move it to the other side. And now that I have one nice big block here all on its own, everything under the radical, I can get rid of that by cubing it, as long as I do the same to the other side. So the cube and the cube root cancel each other out. Remember to keep your parentheses here. And then to solve, I just have to bring the 1 over here. And that gives me my inverse function. And I'm done. Now let's try a really hard one. And this is about as bad as they're going to get. Steps are exactly the same. Replace f of x with y. And then swap the x's and the y's. And you'll note that I had to replace both of those x's with y's. And now I want to solve for y, but I have a problem. I have a y in the denominator. So what I'm going to do is clear the fractions by multiplying both sides by y plus 5. And on the right-hand side, that just cancels out. But on the left-hand side, I'm going to have to multiply the x times the y and the 5. So I get xy plus 5x equals y plus 3. And now I have another problem. I have y's all over the place, on the left and on the right. So what I'm going to do is bring every term with a y over to the left and everything else over to the right. And it doesn't matter whether you put the 5x first or not. I just didn't want a leading negative, so I moved it behind the 3. But either way is fine here. And now we have all our y's on one side, everything else on the other. And now comes a trick that you're going to use quite a bit when you get to logarithms. Somehow I have to isolate that y. So what I'm going to do is divide a y out of each term. And when I divide a y out of this, I get an x. And when I divide a y out of this, I get a 1. And now I have something I can work with. I have a y, a coefficient on the y, which is this whole thing, even though it looks kind of nasty, and this. So all I have to do now is divide by the coefficient. They cancel. And my inverse function is 3 minus 5x over x minus 1.